So in this video, I'll be explaining about the operation of basic gate. The first gate I'm taking here is the OR operation. So the OR operation, the gates are like here the implementation of any PLC programming is based on three main parameters. The three main parameters are the first one is the normally open, and the second one is the normally closed, and the third one is the output. So the output is used as a coil here, and the normally open and normally closed. So normally open and normally closed are the two main switches which will be acting as basically when the contact is on, it is the output device gets turned on. So when it is normally closed, the output device, the status of the output device is always an off state. So here the output, this is the symbol of the representation of the output symbol. So we'll see how the OR operation is working. So OR connections are made, the connections have been parallel. So whatever you are seeing here as a L1 is called as a rung, and the inner structure is called as the ladder. So here A and B, when you are considering with A and B are the two inputs. So this is a standard truth table, that is 0 0 0 1 1 0 1 1. So the output of the OR gate, like the this particular ladder diagram should be designed based on this particular symbol. So here when A is 0 and B is 0, so A is connected to B in parallel. So A is 0 and B is 0. So when it is 0, it is be that A is considered as normally open and B is considered as normally open. So the output of this is 0. So the output at this particular point at 1 is 0, and this output device does not turn on. So when A is 0 and B is 1, so A is 0, so the current which will be acting at whatever the old current or the voltage which is flowing across the A terminal will be acting as an open circuited, but B is energized, B is turned on, so B is on. So the output of B will be 1. So it is connected in a parallel. So the current flows across this particular terminal and goes towards the output device. The device will turn on. So the output of this is 1. Once again, here also A is 1 and B is 0. So B will be acting as a open circuited and A will be acting as a short circuited. Like here it is considered as the current is flowing across this particular terminal and makes the device to get on. In the last case, both the inputs are high. When A is also high and B is also high, the current flows across both the terminals and make the output device to get turned on. So based on this particular parameter, we'll try to design the ladder diagram using our RS Logic Micro English. You can able to see the different types of the symbols which can be used here. So the first symbol you can able to see examine if closed. Examine if closed is nothing but the normally open circuit. Examine if open, it is nothing but the normally closed circuit. So we need to go with this particular symbol. You need to select at this particular point and you need to switch this. So you are getting this particular question mark and the address. So you require two inputs has been required. So it should be connected in a parallel. So what we need to do here is we need to bring a branch here and we need to connect it across this particular terminal, and you need to insert one more input at this particular point. So two inputs have been created. This is input A and input B, and you require one output at this particular at the other end. So this is one output which has been created. So you need to give, there is a question mark, still our program is incomplete. So there is a question mark at this particular point. So input, you can able to see there are a data files. So output is represented as O0, input is represented as I1. So in any of the programming if we take, we need to provide with a proper addressing data files. So as of now, we are concentrating only on the 0 and 1. So the input is represented as O and output is represented as 0 and input is represented as 1. So we need to give the input address as I semicolon 0/0. So this is nothing but the first bit of the first address we are taking. So second one we will be considering as I0:0. 0:1. This is nothing but the second input. This is B, and here we can give the naming and as A. So this is A. A and B are the two inputs, and here also now we are talking about the output. It should be represented in terms of O:0/0, because it is like the first input it is given as 0, second input it is given as 1. The third in here, the output, the first output we are considering, hence it is output 0/0. So here also we can try to give it, you can name it as this as a lamp or any particular motor or fan based on the what kind of output device you have connected. So my program is completed now. So here I have given the address as I0/0, I0/1, and now here the output also is represented as O0/0. So this is nothing but the ladder diagram has been completed. Now you need to save your file. You can save it on your desktop, or you can create your own file and you can give it as an OR gate. So once your program has been saved here, so once your program has been saved, now you need to upload this particular program. So since we are not doing any sorts of interfacing with any physical hardware, so we are working only on the simulation. So you need to upload it. Once you upload your program, it will be visible at this particular point. You can able to see here, this is, as of now it is blank. Once you try to upload it or download your program, so go to downloads. So I'll repeat once again, you can go here in near the offline and say download and press OK. It is asking, do you want to download the procedure? Say yes. And do you want to go online? Press yes. So once it has been downloaded, you can go and see here the whatever the file name which you have given, that file name will be existing at this particular point. So you can able to start now. Your program is running and you make sure that ladder will be running. If your ladder is running, there will be no error and your program is perfect. So once again, go to the remote program and say run your program. So once you run your program, so the ladder gets energized. Both the end, it has been connected with a green line. So this indicates that your program is ready for the operation. Now you can try to see that. As of now, the input, like for example, if you want to see the values, if you just double click on this particular thing, if you just double click on the input, you can able to see this. So as of now, the address input I:0/0, this is my address. This is nothing but A and this is nothing but B. Both the input value is 0 now. And for output also, you can see here, you can keep this at this particular point and you can check. So the output is also 0. So what does our truth table says that? So our truth table is when both the inputs are 0, the output is 0. That is what it is showing. When both the inputs are 0, the output is 0. So if I change any one of the input now, so I'll make it as A as 1. So now 1 and 0. So 1 and 0 is the output is 1. 1 and 0, the output is 1. So if I make it as 0 and 1, if I make it as 0 and 1, so 0 and 1, this is also 1. So you can able to see there is a changes which is happening. I am not changing anything at the output point. So 0 and 1 or 1 and 0 is when both the inputs are also high. So this is the output will be high. So this is the one way of giving the input from here. The one more way of giving the input is you can select whichever the input you want. For example, if I want to change the value of A, now as of now the A value is 1. So to change the value of A, you can use the right click on that particular A switch and press the toggle switch. So when you press toggle it, it will go to the 0. The status of input A is 0. It has been changed to 0. Now here also you can change it to toggle bit. You can change it, make it sure this gets go off. So this is how the ladder programming works for a basic operation of an OR gate.